Thank you for joining us again. Today we have with us Nathan Sturtevant, who is a professor at the University of Alberta and a fellow with the Alberta Machine Intelligence Institute. Nathan is an expert in AI with a focus on heuristics and search. Thank you for joining us today, Nathan.
Thank you, Spencer.
I'm wondering if you can quickly introduce yourself and tell us a little bit about what your areas of research interests are.
Sure. I'm a professor at the University of Alberta, and I've worked at a number of different institutions. And a lot of the work that I've done has been related to games, but more broadly, I work in the field of artificial intelligence. The field that I primarily work in is combinatorial search. Not something like web search, but it's a question of how can we look at a problem that has a combinatorial, there's many, many ways that we could think about trying to solve the problem, and how can we search through all those combinations and try and solve them. And so we've applied that to things like pathfinding in games, but we're also looking at that in areas like game design or other things like that.
Can you maybe tell us about a particular project or research line that you're kind of very excited about these days?
One of them has to do with just going back and looking at the theoretical foundations of the basic algorithms that are used for search. So one of the most common algorithms is a very, very simple algorithm, or fairly simple algorithm to implement. It's sitting inside almost every game, and it's used really broadly. And we've looked at the theoretical foundations of that, particularly when we're trying to find faster and suboptimal solutions. We trade suboptimality for finding faster solutions. We found that there's a lot of things we could understand theoretical that's led to a whole range of new algorithms that are very, very simple to implement and very often can give us much better performance in practice. And then we've also been looking at the question how we can augment human intelligence. And this is particular in the area of puzzle design. How can we use puzzles to, or how can we have a computer use the computational power of a computer to help humans design puzzles more quickly? And so this is a place where we'd like to use AI and the capabilities of the AI to augment the human intelligence. So human might have a design goal, the human may have something that they're thinking about or place they want to go, and we like the computer not to take over the world or anything like this, but we wanted just the computer to be there to assist a human and to be able to answer questions more quickly than a human might be able to do on their own.
And so what sorts of ways would this be used in, say, a video game?
Sure. So this is the type of thing that would actually happen in the design process for a game. And what we've done is we've taken a number of different games, puzzle games that other people have written. We've taken them and we've re-implemented them with personal copies or our own implementation. And then we've built tools around that are able to analyze and come up with large sets of very interesting puzzles. But the general idea there is that we often found that you can take a puzzle and you can just make very, very small changes and end up with a second very, very interesting puzzle. So this would be a way that as a designer was working through this space that they could look and find things that maybe they overlooked or they didn't realize the consequences of certain design changes that they were making.
You also spoke a little bit about search algorithms. Can you tell us about how you would see, improvements to search algorithms being used in gaming?
If we look at a pathfinding system, what's going on is we need a representation of the world. The representation is some sort of abstraction of the low-level physics. And given then that representation of the world, we often search through that to try and get a path to our goal. And when we do that search, that can be very expensive. Oftentimes we choose a representation that tries to make that less expensive. But one of the things that's very commonly done is instead of trying to find the optimal path, which might, actually the optimal path is optimal in some abstract space, which maybe isn't even what a human knows or cares about. And the type of suboptimalities that the algorithm might give us might be things that humans would never notice. And so we're able to do that to find paths much more quickly. And what we've understood is that for these algorithms, there's very, very small changes we can make that allow them to be even more efficient. And so this is just basically anybody who's got pathfinding running anywhere inside a game. There's very, very simple one-line changes basically that you can make that can improve the performance with very, very little effort.
So making pathfinding happen a little bit faster and use less of the computing resources of the system.
Yeah, that's actually a really important point. So right, in a game, it's a real-time system. As a real-time system, then you're limited amount of time every frame to do the computation that you want. And so even if we can make the pathfinding 10 or 20% faster, that frees up extra time to handle either graphics or handle other AI systems or just other things that need to be done to keep the game running smoothly.
For sure. Well, thank you very much. That was really interesting, Nathan. Really interesting to hear about how heuristics and search can have a hand in video games. Thank you so much for joining us today.
Thank you.